These are the solutions for SAT practice test number 2, 11 through 20 on the no calculator part, which corresponds to assignment 11 in test prep. Okay, so problem 11 is getting at the notion of perpendicularity. There's a nice long word for you. And so you need to look at the slope of line L. Rise over run. So you rise 8 and you run 2. So that slope is 4. And so the equation of the line would have a slope that's a negative reciprocal. So what is the negative reciprocal of 4? That is negative 1/4. And so just look for the equation that is a slope of negative 1/4, and it is D. 12 is about a composition of functions, so f of g of x. So that means the entire g of x function, which is 2x squared, gets substituted in for x in the f function. I'll say that again. The entire g of x function becomes x in the f of x function. Remember, what's ever inside those parentheses, that's x in the outermost function. So g of x becomes x. So you substitute that in, crunch it out. All you got to do is the 3 times 2 on the bottom, and you get A. 13, this one's a little bit goofy. They've got some distractors here. So the 0.26 is on f of x. So that means that x is 2 and f of x is 6. Or you could say it like this, f of 2 equals 6, either way, in that notation language. If g of x equals 2 times f of x, and g of x also contains the 0.2 something, so we're still talking about when x is 2, so we can use f of x is 6. So 2 times 6 is what you would want to do to get the answer. Okay, so it would be 212 would be the point. And then you can see 2 times f of x equals the g of x function. Problem 14, good old SOHCAHTOA. Okay, so sine and cosine. And basically, so the distance between the top of the flagpole and the end of the shadow is 10. So this length here. What is the difference between the height of the flagpole and the length of the shadow in terms of x? Okay, so the shadow is the adjacent leg, the flagpole is the opposite. This is kind of like the ray of the sun here, and then you have this shadow image that happens on the ground. So you have to get at, with respect to x, what the sine and cosine are. So here's the sine and cosine, and then you need to solve for it, and this is what makes this hard. You need to solve for the opposite and the adjacent sides because we want the difference between them in terms of, I guess, right triangle trig. So when you do that, you get 10, you multiply both sides by 10, or think of like a cross product, 10 times sine x, 10 times cosine x, and then you take that difference. That's a hard problem. And although it involves basic knowledge of hypotenuse in there, it involves basic knowledge of right triangle trig. The solution to the problem is you have to think. You have to be able to see what to do. So that makes that a hard problem. I would put it in the hard category. I put this next one in the hard category too. Problem 15. So you're going to have to draw this auxiliary line, kind of complete this rectangle, and then realize that each chord has a length of r. And so the circle above has radius r. Okay, so that's how I've got this here. This would be 2r, the diameter, and then each chord also has a length of r. So what we're saying is that this length here is the same as the length of this chord. You got to draw all that out, and that becomes challenging. So we want the area of the rectangle. So the area of the rectangle is x times r. Well, that's, I stated that right here. The problem is we need to have it in terms of r, everything in terms of r. So what you have to do is devise a way to solve for x, because we need to replace it down here, because r times x is the area of the rectangle. So you need to come up with something in terms of x and r. Well, that is the Pythagorean theorem. I'll say this, anytime you have like a rectangle inside of a circle or a square inside of a circle, get ready to use the Pythagorean theorem every time. So trace the right angle, x squared plus r squared, that's your a squared plus b squared equals 2r squared. Make sure that you have parentheses there. And so that's 4r squared, 2r times 2r. We want to solve for x because we need it in terms of r. And so subtract r squared over, it's like terms, so that's 3r squared. Take the square root, you get the square root of 3r. And then that gets replaced. That's a hard problem. So they're going to throw these harder problems at you for sure. This isn't too bad. You have to realize he has the same number of quarters and nickels. How many quarters does he have? So that, you know, these are equal, so you can replace, I just put x where y was. This is a system of equations. Okay, so you see the money amounts here. So 0.30 x equals 690. How do you solve that? You can move the decimal, you know, if you move it one place to the right, just move it one place to the right on the right side there, and then divide it by 3. So 23 is how many quarters, and then he has 23 nickels. And so if you put that back in, you would get it. That's even a little bit, without a calculator, a little bit harder. What is a value of x that satisfies this system? So what you need to do is realize that this is a linear quadratic system, which you're going to set them equal to each other after you solve for y, of course. Take everything to one side. And so what is the value of x? So this involves factoring by sight. Okay, so you got to get this far with it. This is something we do in algebra 2. And then you need to think about, okay, 2x squared, that has to be 2x and x. There's not a common factor. And then -6. How do I break -6 apart so that I get, you know, when I FOIL this back, I get the 2x squared minus 11x minus 6. Well, it has to be -6 over here and +1 here. You're welcome to do the quadratic formula if you can't figure out that factoring, but that's probably equally as difficult. So 6 or -1/2. It says what is a value of x. That satisfies that. So either one would be fine. Problem 18. I promise you they're going to ask you a question with distance, rate, and time. So both of these situations are, I call them dirt problems. Both of these situations are rate times time. And the time is not 20. It's 1/3 of an hour because we have to keep things in miles and hours. So 15 times 1/3 plus 3 times 1/3. So after 20 minutes, they're coming towards each other. How far were they? So, you know, how much are they going to cover after that 20 minutes? So you add up both r times t's and you get 6 minutes. Anytime you see something, you know, like this, where you're talking miles per hour and then time going on, you need to write this down because that's what's coming in your figuring. Please, this is not a hard problem. Pick a number such that when you divide by 12, the remainder is 8. Well, how about 20? Okay, so when the positive integer u is divided by 12, so I was looking at the sum, I'm sorry. So let u be 20. So 20 over 12 is Need to write that down. 20 over 12 is 1, remainder 8. Okay, so then what is the remainder when you do this? So 20 plus 10, 30 over 12, 2, remainder 6. So 24, or 30 minus 24 is the remainder of 6. So use numbers when you can. Usually the giveaway is you have in your choices variable solution choices. What is one possible value of A for this equation? So here we go again. We've set them equal. You got to multiply the 2 through, and the 2a to the thirds drop out. Take all your terms to one side, and you're presented with a factoring problem again. Quadratic formula or factoring, probably site by site factoring is the best way. 2a and a, then you have to figure out, you know, through the reverse FOIL, that's what this is. Two numbers that multiply to positive 15. Well, you're either dealing with 1 and 15, negative 1 and 15, or 3 and 5, negative 3, negative 5. And because of that negative 13, you're going to probably choose them both to be negatives. Well, it's a matter of moving them around, checking them out in there. Negative 1, negative 15, nope. Negative 3, negative 5, nope. Well, yes, in this order. Okay, so it would matter if you put the negative 5 first, then the negative 3. So harder problem because you have to put that factoring together. If this was on the calculator part, then this becomes much easier with getting these. Certainly you can try some guessing and checking, although, you know, by the time you get to 5, that's a little bit of, you know, start with 0, 1, 2, 3, 4, because they're not going to look at your work. They're going to look at these answers. So if you get stuck with factoring, just like this one here, you know, start with 0. Usually there's going to be a positive. Then try 1, try 2, 3, 4, 5, 6. You do have some work to do, but hopefully you can do some of that work, you know, in your answer sheet or your test booklet area there. All right, so that is problems 11 through 20 for test prep on the second SAT practice test.